we see at 24 hours, there's no activation there's no IL-8 mRNA. At 48 hours, there's a very small amount, approximately 5-fold. But at 72 hours, this is drastically increased. At the beginning of the study, again, we knew that multiple dengue viral proteins did interact with several very important signaling pathways. And yet only one protein was known to induce IL-8 secretion. Dengue virus induces IL-8 secretion from many different cell types, suggesting it may actually be a very important inflammatory mediator. So I asked the question of whether dengue virus has a fail-safe mechanism to induce IL-8. Rather than looking at multiple different cell types for IL-8 secretion, instead, I noted that IL-8 secretion and IL-8 promoter activation were separate but related processes. And I asked the question, do viral proteins other than NS5 activate the IL-8 promoter? I did this again by the luciferase assay. And this time I used our expression vector for dengue viral proteins. It's driven by the cytomegalovirus promoter. And most of the dengue viral proteins are tagged with HIS and B5 at the end. This is co-transfected in with our Firefly luciferase constructs. And our luciferase assay is then performed at 24 hours post-transfection. We had all of the dengue viral proteins, again, as Carrie had previously tested. In addition, I included two constructs that Carrie did not include in her previous paper. The first was this PREM-E construct, which I noted at the beginning has the potential to induce the formation of virus-like particles. I also included this NS1G as well for comparison. This data is presented as fold, again, over pcDNA, the negative control. MAL is shown here as the positive control. And as I've highlighted already off top of the title, we saw that PREM-E, NS1G, NS4B, and NS5 activated the IL-8 promoter. Now, capsid here showed a trend towards dose-dependent induction, but ultimately, by this statistical analysis, was not significant. PREM and E separately did not induce the IL-8 promoter, nor did when we co-transfected these two plasmids in together. But PREM and E expressed together in this form did induce IL-8 secretion. NS1 did not induce activate the IL-8 promoter. NS1G, however, did nicely dose-dependently induce the IL-8 promoter. NS2A, 2B, 3, 4A, all did not induce, but NS4B did, as did NS5, as was previously characterized. Again, the IL-8 promoter is regulated by AP1, CBP, and FGABA-B, which also regulate several other inflammatory cytokines that are very important to infection. Now, of note, RANTES, at the time we did this study, did not have any other known activators that we could find. And we happen to have the promoter as a luciferase construct. So we asked the question, does NS5 activate the similarly regulated RANTES promoter? And what we saw, again, this is actually fold induction over pcDNA. We used NS1 as a negative control, and we saw that just with NS5, there was a nice dose-dependent induction of the RANTES promoter as well. We went on to look at other inflammatory cytokines encouraged by this result. To do this, we used a PCR array. We transfected cells either with pcDNA as the native control or NS5, isolated the mRNA, and then we put the mRNA on two plates that, like our quantitative RT-PCR, contain primary and probe to 84 test genes and 12 controls. We saw that IL-8 had a nice fold induction, as did TNF, had a pretty good fold induction the other genes that we were watching for, IL-6, IL-1 beta, and interferon beta 1, we did not see a significant fold change. We did see increases in other factors, such as inhibin beta alpha, which had a 5.3 increase, and lymphotoxin alpha had a 2.5 decrease. But these do not contain NF-kappa B, AP1, or CBP, and therefore we chose to focus just on TNF. By QRT, we further confirmed that TNF was being induced by transfection with NS5. In this case, fold induction over pcDNA, shown over here, and we have a comparison with IL-8. It's a lower level than IL-8, but it's still a pretty good fold induction. So the summary to this aim, we asked the question, does expression of dengue viral proteins other than NS5 activate IL-8 transcription? And we saw that pre-ME, NS1G, and NS4B, as well as previously characterized NS5, all activate the IL-8 promoter. Does expression of NS5 activate transcription of other cytokines? We saw that NS5 does activate the RANTES promoter, and we further found by PCR array that NS5 induced TNF-alpha mRNA. Moving on to the second aim, we focused on which transcription factors are activated by dengue viral proteins. Now, this is a map of the actual, these are the actual binding sequences of the transcription factors within IL-8. The common binding motifs are shown up top, and then this is a consensus binding sequence shown here, as compared to the IL-8 promoter shown here. We used tandem repeats of each of these consensus binding sequences to drive luciferase expression. We transfected these in order to get an idea of which transcription factors were actually being activated during dengue viral expression. There are differences between the consensus binding sequence and the IL-8 promoter binding sequence, which should be noted. With AP1, we were very encouraged. This is again fold induction over pcDNA. And we saw that pre-ME, NS1G, and NS5 all activated the AP1 promoter, and this correlated with what we saw with IL-8 induction. In addition, we saw that capsid, again, showed a trend towards dose-dependent induction, similar to what we saw with the IL-8 promoter. We also noted that NS4B showed a trend towards dose-dependent induction, but ultimately, by this statistical analysis, was deemed not significant. Pre-M and pre-M plus E did not induce IL-8, but pre-ME did. NS1 versus NS1G. NS1 did not activate the IL-8 promoter, but NS1G did. And 2A, 2B, 3, and NS4A all were negative. CBP and NF-kappa B all showed very low induction. We went ahead and used a separate statistical analysis, and that was less stringent. In this case, it was compared to the negative control and did not take into account dose dependency. Therefore, although I report here statistically significant induction, this should be interpreted with caution. So by this statistical analysis, we saw that capsid, premembrane, E, and pre-ME all induced this CBP-mediated luciferase reporter, as did NS5. We also saw with NF-kappa B that capsid, the 100 nanogram dosage of E, the 80 and 100 nanogram dosage of pre-ME, and NS1G, as well as NS5, all induced statistically significant activation of the NF-kappa B reporter. So I've summarized this here. And I particularly want to highlight that with AP1, what we saw correlated with the IL-8 promoter. C did not have statistically significant induction in IL-8 or AP1, but did show trends towards dose-dependent induction. NS4B also induced the IL-8 promoter and had a trend towards inducing an AQ1 mediated order. Pre-ME, NS1G, and NS5 all induced both ILate and ILate promoter-driven and AQ1 mediated luciferase reporters. With CBP and NF-kappa B, we saw some with C. In the case of pre-M, we saw some upregulated CBP. With E, we saw some of both CBP and NF-kappa B. And with pre-ME, we saw a little bit with both. NS1G only showed a little bit of NF-kappa B at the highest dosage, or at the 80 and 100 nanogram dosage. And NS5 showed the most statistical significance, statistically significant activation of the CBP and NF-kappa B promoter when we loosened the restrictions of the statistical analysis. And just to note, these results with NS5 did correlate with what Carey had previously found. We went ahead and asked a slightly different question next, of whether activation of the ILate promoter depended on any single transcription